Good evening, class. I hope you're all doing well. Today is Thursday, 11/12/2020, and we're going to start chapter 12 of our textbook, which is Python networking. With Python networking, we have a number of modules that we're going to cover, including socket programming. We already covered some CGI programming and some of the regular expression commands, as well as regular expression module we discussed last week when we were covering chapter 11. In continuation, chapter 11, and it started with chapter 12 last week. We covered CGI programming, common gateway interface, and today we're going to cover a number of other modules that are discussed in chapter 12, including socket programming, URL lib 3, request, and so on. All of those ones we will be discussing, and I have a number of examples that I could show you here. There's a client version for socket programming and as a server version. We will discuss what is socket, what is how to connect each one of them by going into these examples. And then we have the request methods or request modules. The request module, when we discuss, it has a number of methods, especially the get method and the post method that are in, we experience already with CGIs. So with get method and post method, we have a number of examples. We will be discussing it. This is right here is the socket client version of it. So if you just create a socket by loading into a memory, the module, actually importing it, and when you do import, it actually loads the socket module into memory, and then you connect to a host and a port. So what is a socket? Socket is basically is a two-way communication, a one-way communication within the socket. Both end is talking through the socket itself. It's not like a two-end connection. It's one end connection from client and server, but the connections are end-to-end communicating through the protocol you're using. In this case, when we do import socket, socket is the module, and the method that we are calling it is also called socket. So the socket method requires two arguments. One is the socket AF underscore INET. In this case, I'll actually open up the PyCharm and show you all the options for address family. AF stands for address family, or some people say address on the file system. So the file system in this case, or address family in this case, is INET, internet, which is for connecting to the internet. And then the next parameter is sock underscore stream. Sock underscore stream is basically for TCP IP. Sock is, you see underscore stream meaning that it is connection oriented. It is not connectionless. If it was UDP, it would be a user datagram protocol. It would be a different call. And so since it's a TCP, transmission control protocol, internet protocol, this is stream, meaning that it is connecting through TCP port, and it is more reliable. It is connection oriented. And so you basically are getting a connection, and the connection is established. Then it is through that communication, you read and write data from that stream, which is TCP. And then once you connect through that stream, if it was a UDP, then it would be connection less, but we're doing connection oriented. So all the protocol that you have been using, whether you're using secure copy, scopy, SSH, or secure FTP or FTP, all these apps that you're connecting to another remote site, normally they are connection oriented, meaning that you authenticate, you have a connection, and then that connection is established, you communicate through that one. But a UDP, user datagram protocol, is almost like a text message. You send a message, you are not connected anywhere. You just send a message through UDP, it sends the packet, and if it is not sent, it could have a retry button to just say retry it, but it is not guaranteed on the, yet it is very fast for a small amount of package to send it. So depending on the connection, you do different connection. Um, Depending on the needs, you make different connection. Here we are making a TCP connection through this IP address and through this port. So normally if you put the host name like our unix.com, that depends on the DNS, and the DNS has to resolve it. DNS stands for domain name services, and normally everywhere you go on the internet, you're typing a host name like google.com, amazon.com, ibm.com, pasadena.edu, jpl.nasa.gov. That's a domain name. The domain name normally resolves to an IP address, and that IP address is the either IP version 4 address or IP version 6. These are all currently, the majority of the IP address that you see are IP version 4. IP version 6 is out there, but very few companies are still using it because IP version 4, it has a limitation in terms of 4 billions of IPs, for example, or larger. But then if you need larger than that one, you need a 128-bit kind of IP address resolution that to resolve it. This is 32-bit. Each octet is resolving to a 8-bit, so 4 times 8 is 32, and then the IP version 6 is 128, which means that you will never run out of IP addresses. So that Cisco Internet of Everything, that one is actually, you can connect all your devices in your hardware at home, laptop, cell phone, TV, laundry, anything, freezer, anything that you have on the internet, and they could still get a valid IP address with IP version 6. With IP version 4, that limitation will reach out, and then you will be limited because of 2 to the power of 32. It's like 4 gig that in size, so that's going to have your limitation. But before I go further on this one, I'm just gonna browse through the this page. So I have a number of pages for documentation for you to follow from this class, as well as afterward when you're listening to the videos. You can watch it and you can browse through these documentation. It helps you. So I'm gonna go through this and then I'll show you each of these programs one by one with demo on PyCharm or Windows or Linux environment or Unix environment. Excuse me. So this is the server version. As you can see on the client side, we are making connection. We're sending and receiving, and this is the server version, which I mentioned that I will discuss. This is my localhost.py, which is basically connecting to the Loopback interface. I'm going to also cover these terminology that I'm discussing, whether I say DNS, TCP/IP, or SSL, TLS, HTTP, HTTPS, what they are. So I'll have a page for that one as well on today's topic. I'll discuss those ones first. But let me just show you some of these docs. So in case if you're interested in learning more, you could open this PDF and read the example and play around at the lab times, all of these through your practice to see exactly. You don't have to connect to the same URL I'm connecting here, but if you're doing like a post, you need the same URL that I'm connecting, right? Like here, I'm connecting to http://bin.org, because this post directory has to be in the path in order to just work for your post request method. So this is one of the documentation, and going on the same module, I have two more documentation that I will show you, and then we jump in into the lecture. Do you have any question while this one is loading? Okay, I see there's 9 of us all together. And so chapter 12, we already opened this one, networking Windows, Unix, Linux, and then lecture for Thursday. Let me open this one first. This one is basically the terminologies and also commands that you type in on Unix operating system or Linux or Windows. So I mentioned here DNS. DNS stands for Domain Name Services. So when you type in google.com, like for example here, google.com, my machine, whether I'm typing google.com on a browser or I'm typing from command line, I could do, like for example, if I want to just see if Google is up, I could say ping google.com. And if I see the packets that are coming and the 4 packets that here that is connecting, the time to live is 117. None of these packets you can see it was lost. That means Google is up and running. But when I do NS lookup, which stands for name server lookup, and so google.com, it will just give me an IP address on this. Saying that Google IP address says this is the IP version 4 and this is IP version 6 address for it. So if I say ping 172.217.14.78 is the same thing as I was getting for google.com because that site is up. And if I do the same thing for NSLOOKUP, say our unix.com, my site, I get this IP address. This is for local subnet, so I could say ping our unix.com, it will ping also. And the fact that this one is resolving to this IP address, it depends on what machine I'm using for. So on this machine, if the local machine has to be on the internet having an IP address by itself. Since I'm connected with Frontier, on this local machine, I have, if I do ipconfig basically give me all my IP configuration, and this is my current IP address for the local host. So I do host name, I see that this is the host name for it, which is generic, but because I'm connecting to this IP address, on my subnet, if I do a netstat minus -an, it will show me all the network connection. But in this case, I'm going to do a RN for routing numbers. And then as you can see, let me do a pipe more. So as you can see, my gateway is up and running. And then at some point, I will have the gateway 254.254. And then this is my local IP address for this machine. Yet on the same network, if I go back to my Unix machines, right here. And then this is mywebuniversity.com. So if I do a clear screen here and then do netstat minus rn, you can see that on this one, the IP address, the gateway is actually 254, same gateway, right? And then IP address of this one is not showing here, but it's actually fconfig minus a. It will show that right here. And that's also on the etc host file. So there's a file called on Unix and on Windows also for resolving the gateway. And when I do netstat minus rn, how do I know that I'm connecting to the net or gateway? If I ping my gateway 192.168.254.254, now I'm connecting to that gateway. Through that gateway, it is resolving my IP address to a known IP address on the internet. So, and that IP address is actually inside a file called resolve.com file. This is where DNS is basically set up to say, when I try to connect to the internet, use this as gateway, as you can see here, use that as a gateway to connect me to outside of my network. If I don't have this gateway and I cannot ping the main gateway, then I will not be able to go outside of my network. So this enables me to connect outside. And then the word DNS, in this case, if I do nslookup our unix.com, basically, or mywebuniversity.com, let's say, in this case, mywebuniversity.com. And you can see this is the IP address that's coming for mywebuniversity.com, because I did a DHCP connection from this, but I did a dynamic DHCP with dynamic IP configuration through another service provider. I got this one. So how I get this IP address, if I go to my local machine here, there's a website called whatismyipaddress.com. It tells me that this is .13 is my IP address. That's how I'm going to be recognized on the internet. Then I go my service provider. If they provide dynamic DHCP, then I could just configure it, and now I'm on the internet as a result of that. So if I come in here and then I type in ourunix.com, automatically goes to my web server. But the web server itself is at HTTP web server that is running off of this machine called our, this machine right here called ourunix.com. So if I just say host name here, you can see ourunix.com. And if I look at the HTTP, right here is the Apache configuration. Why am I showing you this? Because the HTTP protocol, this is the daemon that is listening on this server. So on this server, I'm listening to port 8080. If I do a netstat minus an grep for 8080, you can see that I'm listening to port 8080 here on this machine, and it's right here, listen. Or I could do same thing with netstat minus an grep for listen, and then you could see if I just do with minus I, because the word listen is all uppercase, so I could say ignore the case, it will show it. Now I am looking at port 8080 and it is there. I could also do another filter. This is an example of filtering and at the same time called piping on Unix. So I'm piping one command to the next command and the next command. This is also called inter-process communication. Between the processes, they're using the shared memory as message passing. So inter-process, and then I do grep 80, I could see everything where that is 80. And if I'm just only interested in 8080, I could do that and then get that information for it. But what is happening here on when I type in our unix.com, so what happens is that the first thing that my machine does, it goes to consult this resolve.com file. And that's going to say, what is the name server to resolve this host name to an IP address? I typed in, like, say, ping our unix.com. How does it know? By just saying this, our unix.com, it says, okay, let me find out this gateway that this machine is doing it. Since this gateway is pingable, it goes to Frontier, in my case, router, and then connects to their name server, this IP address, and then it's going to say, do you know a host name called our unix.com that you can provide me an IP address? And then they say on the top layer, it says, no, I don't know that one, but I know there's a dot domain. It finds the dot domain, then it says, okay, go to the name server of the dot domain, and then if it's .edu, .gov, .net, whatever it is, it's going to hit the first top layer, which is the root layer with the dot domain. Then it's going to say, oh, and you're looking for a com. So now let me just, the dot domain is going to send it to another name server called com, the name servers. So if it was .gov, it would send it to the gov. If it was .net, it would send it to .net. And then from there, and that .com is going to say, I don't know a website in here that is called exactly ourunix.com, but I know something called www.ourunix.com. So then it's going to send it to that there. And then at that time, it's going to come back to the Frontier and it's going to say, oh, you're having an IP address on this host, which is this host name, and that host name has an IP address, IP config. You can see that fconfig minus A will give me all the IPs, and it says, okay, so this host name is resolving to this IP address, and that IP address is on the machine. And when I do ns lookup, our unix.com, it finds out that IP address right there, because this one is there. And since this one is up, if this one was down, then the name resolution would still fail. So you could do a trace route on our unix.com. Sorry, this is trace route. So when you're doing on Linux or Windows or Linux or Unix, it is trace route. If you're doing it on Windows, it's trace RT equivalent. So you can see that it is right away it headed because it's on the current machine. But if I just do something else like IBM.com, it's going to try to hop from my gateway to another one and another one till it finds it. And if it resolves it, it is going to do it. Otherwise, it's going to have that time to live timeout, and then it's going to say it reached the maximum connection. Maybe the host is down or something. So this is how you resolve it. The other term that I was using here is DHCP. This stands for Dynamic Host Configuration Protocol. The dynamic host configuration protocol is dynamic. It's not static. DNS is always resolving to a static or dynamic, but the fact that you configure your machine to resolve to static, that static will always be at the same IP address. It will not change. With DHCP, you get to connect to, let's say, Frontier network. You get a list of pools from the pool, available pool. Once you have that IP address, like I was showing you here, what is my IP address? You could run it on this one on your machine, you will get a different IP address. This is every time you reboot your machine, you will get a different IP address from the pool, unless the same IP address was available the next time you reboot it. Sometimes they refresh it and it give you a new setting. But with DNS, it's always static mostly because you want a reliability, so you don't lose your connection just because the host resolved to a different IP address. And then the fconfig, I already showed you. ipconfig is, I already showed you on Windows, you run ipconfig to get it there and that information. And if you're looking for like IP version 4, you could do just clear the screen here. You say ipconfig and then say find/i and then IP version 4. So just to see that one, you see the current IP version 4 there. You could search for whatever you want. Well, this is a find similar to a grep command on Linux or Unix. So the next topic here is netstat. Netstat, we did show you example of it. And LSOF has a list of open file system. Why am I showing you these commands? Because whatever you do in programming languages like Python, you write a socket program, then you need to understand how that socket is open on the system, how they are established. So whether you write it on Windows or Linux, as an example, let me show you the LSOF with our first socket program. So I'm going to go to one of the Linux machine here. Let me Control-C out of this. Okay, this one is Unix. Clear the screen here. I'm going to open up this one. Okay, clear the screen. So here we have a number of files. And one of the files is called myserver.py. Okay, so I'm going to vi myserver.py and show you the steps here. Let me do set list so you can see all the new line characters. Set no list. I'm going to remove it because there's no Control-M characters. And then we do set line number for num, set a number, okay. So if you go here, on line number 3, it's just a comment. The first line 5, I'm just importing it. So let's say I import the socket, excuse me. These lines that just came out, I'm going to modify it, remove it. So under the host name, you can see that I want to connect to the local host right now, 254.10. That's the IP address of the current machine and that I'm logged on this server. And then the port is up to me what port I want to listen to. So this, in this case, I used 5555, 4 5s. And then normally the ports are written in a file called etc services. Let me show you that. So this file, etc services, has the list of ports. Any port less than 1024. So 0 is reserved, 1 to 1023 or privileged ports. That means that root or system is using them. Behind that one to 65,535 are ports that you can assign it as custom ports. So you can listen to your application for a particular host. Like for example, let's say I say, okay, what is the port that I'm listening here? If I do a netstat minus an and then look for grep for the word listen, you see that all of these ports are listening. I'm listening to some ports. So if I look at the one that I'm listening here, I'm listening to port 80. You can see the word listen. So let me just do this in a short. I could put the dash W, and that would just, sorry, dash lowercase w. Oh, I'm sorry, I have the caps lock on. And so, okay. So if I just do that one, let me clear the screen to make it look better. Okay, so if you look at that one, I'm listening to port 8080, port 80, port 22. This port 22 is basically SSH. This is port HTTP. This is port secondary HTTP. So whenever you're listening to a port, like I said, this is port 22, the LSOF, list of open files, minus I could give me more details on that port. Say, okay, I'm listening this interface or port number 22, show me what is the process on it and what is, since there's no process associated with it, that is just a server for listening to SSHD. So this is SSHD. And then SSHD, and then if I look at the main process for this one to say, show me the process port of the connection for that one. So I'm going to say LSOF minus P for the process. And in this case, I'm saying minus P1117. So this one, you can see that it's doing that, but because I'm logged on with my regular user, I cannot see it. In order for me to see that the thing, I have to do a sudo or become root. So when you do the sudo, and then you can see that one. And you can see that SSH is listening to that port and all that information is there associated with it. And then if there's any socket or connection established as a result, you could see the number of process as well as the socket there. This is, yeah, right here. Let me see if I see a number for it. Dev null type SSH. And this one is SSH, but MySQL D is using socket. Here, this one, I'm going to try to do our server. And that way you could see how we establish a port there. So right now, if I look at the process, say, show me all the process that has a name my server, it's not having anything. This is my output of my grep itself. So if I do a grep minus v grep out, that one, you will see that there's no process there. But I know that I have a script called myserver.py on this directory that wants to listen to port 555. So right now, if I do a netstat minus an and grep for 555, I have nothing. If I do lsof minus I and then 555, I have nothing, right? So at this time, I'm going to start my process. If I start my process in the foreground, this one, say my server.py, this will run my script inside this one machine. But I want to background it so you can see the command level again. By doing a background, you do an ampersand at the end of your command. This will run my command, but give me my prompt back. And notice that it gave me a process ID already here saying that the server is running. So if I do a ps minus ef grep minus I, my server, you can see that process is up and running because Python spawned it, and that's the process ID that it gave me here. Okay, so now I could do LSOF minus I. I could say minus I 555, and because I'm listening to that port, you can see it's already connected. And if I just do up arrow with netstat minus n grep 555, you will see it. But notice when you do ls minus LSOF, list of open files minus I, the port number, you will get a process ID that you got it from the system originally. So that means I could do LSOF on minus P for the option and then say 12616, show me the process that are invoked. My socket program that I wrote, it actually this is the current working directory of it. And then the version of Python that is spawned the script is Python 3. These all the .so files are shared object files. These are like dynamic link libraries that are used in Windows. On Unix, they call .shared object. Basically, it's shared object, meaning that this is the dependencies that the socket needs in order to make all those calls of bind, listen, and everything else that I have written on them. So let's see what I have on the actual script here. So the actual script, if I do a cat minus n, my server.py, you can see that it is having the host name, which is this machine, the port, and now we use the context manager of Python with socket.socket. Socket is the module that we have created here, and .socket is the method that we are using it. This is, as I mentioned before, the address family is .inet, which is internet, and then the socket stream is TCP. So TCP is another protocol. And earlier I was telling you that there's a file called etc services that or all the ports that you define here are written here. So for example, if I do a grep for HTTP on etc services, that will show port 80 and 443 and other ones that are there, etc services. And then you could see that 80 and 443 and 80. If I do the same thing for SSH, that would show port 22. So those are the protocol, but the ports like 555, you can see it is not allocated, meaning that this number, a user could come in and make a call. So here in this case, it has a UDP, user datagram protocol, or a TCP protocol. So whenever it's /TCP, that's transmission control protocol, and UDP is user datagram protocol. That TCP packets are connection oriented, meaning that you establish a connection through that mechanism like socket or other method that you're doing it through GET method or request or HTTP through authentication mechanism, two-factor authentication. You're basically reading and writing. But with UDP, there's no connection established. You just send the packet and you hope that it receives it on the destination. And the packets are fast on the UDP side because they're smaller packets normally. And then text message is a good example of a UDP. Any application like SSH, right now I'm connecting through SSH on this machine, and I'm running this one. Is I had to authenticate to this machine, and the connection is established. Once I logged out, remember the device here, I had to connect to these machines right here, and then our unix.com is the next one. And by doing that one, now I have a reliable connection. So every time I read and write a packet here, it is just there. So that connection is there. Let me go back to the main my server page. So at this time, the server is listening. So what is listening? Like here, I look for the listen, and then you can see that there's no process there called listen, but there's a process called my server And then if I do a netstat minus an and grep for listen, minus I for listen, then you could see, let me just do minus w, minus w in lowercase. So this one you can see 555 is also there, and the list of that and that one. If I kill that server process, my server, grep minus I my server, if I just kill it and watch, if I do a kill minus 9, this is on Unix, you can just go and terminate a process by force. Minus 15 is graceful, minus 9 is terminated. So now there's no process called my server anymore because I killed it. So if I just do a netstat with W, you can see that the port 555 is not there. And if I just run it again, my server.py, and background it, and run this command again, you will see that it just comes out. But notice that this time it come out with a different process ID. So every time I come in, the process ID may be different, but the process, what port and what host name is listening is the same. So in this case, what does that tell you? That tells you that this is listening. So let me just see if I can connect from another host or from the same host to this machine, to this port, because this port is listening right now. And then, so I have a client version. First of all, let me do a cat minus n my server.py. So it is listening by doing this socket.bind, and notice that this is a Python tuple. The Python tuple in this case is a host combination port. So that's why there's two left parentheses, right parentheses are there, because you cannot just put it in within the bind command. It takes a tuple, not two arguments. If you put it two parameters without being a tuple, it's not going to work. So be careful on that one. And then when you listen to that one, now it's listening to this IP address at this port number. This port number is your choice, but it is between 1024 to 63535, big numbers. You can do that. And then once you listen, at this time, you have to accept connection. So this socket.accept method is basically trying to allow connection from the connection coming in with a specified address. So the client address will be there, as well as a socket connection will be established. This con is a connection that will be based on a socket that you just specify here. And then it says, okay, with con, what can you do? This is the wget statement again. Context manager takes effect here. You do connection established by whatever client comes in. So the client IP address is coming here. Then you say connection established by a client there. And then while this condition is true, which is always true, and then you start reading the data. So the data is coming in 1024, 1 kilobyte of data that you do a con.receive function. So in this case, if there's no data, then you have to break out of the loop, which means that by breaking out of this loop, you're breaking out of the con connection, because that client is no longer connected. They send the data, they no longer wants to send data, so the connection is closed. Then after that, on whatever the client sent, you send that data back to the client, so the data could be received on the client side, what they had communicated with you. And now cat minus n, my client.py. This one is a shorter version. You still do the import the socket. You still do the host name. This port could be a port that you're connecting to. it has to be the server port, and this IP address has to be the IP address of the server that is listening. So this combination is going to be there, but then when you do the Wget statement, again, the same kind of information that we did with the server side, you still establish that connection, but this time instead of accept, listen, bind, you just only do connect. So connect to the tuple again, host and port, which is defined here. Once you connect it, then you can send messages. So here you could do a number of messages within wild read or whatever. You could do read a file and send it, as long as you send the data that if not, while not the data will not be true on the server side. So once that is ended, then the server side is going to send that one. So we were receiving, sending 1024 byte from the server side. Now we're reading the same 1024 byte. But because this is coming as a byte, then we're using the method called representative, which is whatever is the string, if it has a byte object, then it has to print a B in front of it, and so on. So that's why we're doing that one. Now, since we're running my socket, you can see my my server is running, and let's start -an grep 555 or lsof -i colon 555. You can see the running. So I could do lsof P12682, and you can see -p show me the process that are open. Earlier we opened it. It does all these objects that are coming, shared object are coming, and then you can see the file descriptor here. The file descriptor that are open or basically the 0. So stream coming from the display 0, which I could do also like lsof -a -p, and then 12682 -f for file descriptor, minus maybe minus d 0, 1, 2. Yeah, so you can see that this one is basically I'm doing a for kind of like getting it together for all of the file descriptors. And then P is the process ID, and -d file descriptor, and then 0, 1, 2. So any file descriptor that are open, you can see here file descriptor 0 is working on this device, and then it's a character file descriptor, device major number, minor number, and all that things. And then here again 1, 2. This is right now the LSOF is showing that these file descriptors have been opened by the system, because any read and write happening is happening on this pseudo terminal device. So at this time, let me just run the client. So in order to run the client, I say my client.py, and then notice that it says connection refused. Connection refused, error number, and this is connection. So why is happening connection refused? Let's look at the client side here. vi my client.py, and most likely the IP address is our unix.com, because I tested there. So I want to test it on the 20, and I change it to 10. I'm sorry. And then this one, I'm going to do this for this. Now, if I do cat -n my client.py, you could, sorry, cat -n my client.py, you can see that the IP address is here, because if you do fconfig -a, you can see the IP address of where and the my server process is running, my server is running on this host. So netstat minus an of for grep for 555, you could see that it is just basically listening to this port at this. Now I run my client, it will not just say my client.py. I have to give the extension, and it just says received hello ourunix.com. And then now my server.py is done. This process that was up and running, as soon as the client made the connection and received the data back, the socket is closed. So now you can see this process is no longer there. If I just do this one with grep minus v grep, you can see it says the connection was established, a wait for this one from the client side, and time wait. And this will have a time wait because that connection was established, and then the server side, it already said that, okay, a client with this IP address and this port number came online. The connection was established. So now this time I'm going to do this. I'm going to run the myserver.py. And instead of, let me show you that my server.py is, first of all, is no longer on the server. If I do grep minus I, my server, you see that it is not there. Grep minus v grep, it's not there. So if I just say, this time I'm going to run my server in the foreground. So you can see right now, because I'm listening to that port, if I just press 1,000 times or billion times enter, nothing is going to happen until I control C out of it or exit out or kill that process. Because this socket programming is listening to a socket on the server side. So I'm going to demonstrate that one by opening one more terminal on here and just resize this window. Okay. And notice that this one, it says that this is running. You can see that is blank. So here I'd say grep minus I, my server. Now you see that this process is happening, that is listening. And this is the process ID. So if I say lsof minus I colon 12737, yeah, I'm sorry, 12737 minus P. Sorry, that is a process ID, not minus P, that one. You will see all the processes that are open similar to the other one. And then you notice that there's a port for it, 555. So clear the screen here. This time I'm going to do minus I colon 555. So you can see that it is, I'm listening. So because of this, it is listening. If I control C out of this, now it just says that, okay, the Python script, line 25, was listening to the accept, but it was keyboard interrupt. So let's just look at that process. It's no longer there. If I just do it as many times, it's not going to show. But now I'm going to run that one again, clear the screen, and then I'm going to run it on the foreground again. And notice here, this time, we're going to make a connection. It's already there. So at this time, I'm going to clear the screen and say, okay, and that connection is established. Now let me run my client.py. By running my client.py, I should get the hello world here, as well as here the number of connection, the connection that was established. So my client.py no such file or directory. Okay, yeah, that's making sense. I'm on the other directory, so socket. And then run this command, my client.py. Now it did the work. You can see that it says our unix.com here, and then right here it says connection established by this client at this port number. And then here netstat -an grep -I established. You can see if you're looking for the word established, I put a star, and that's good enough to pick up the established. You can see that port 22 right now is still listening because I connected to this machine through SSH. That's for LSOF here, and LSOF as well as other related things. So here the P files. P file is similar to LSOF. On Solaris, in addition to LSOF, they also provide P files. P files is doing similar commands. So on Solaris, if I run the same socket program, let me see. This is the Solaris version, so socket. And then here, clear the screen, fconfig -a, you can see this is a .20 IP address, not .10. And the host name of this one is a Solaris machine, Sun OS. And if I do cut etc host, you can see that our Unix IP address and host name, everything is configured. That one, fconfig -a is showing that. And clear the screen, pwd ls-l, cat my server.py. So this one, as you can see, the IP address is .20. So this one is listening to this IP address on this machine. And then I'm going to run this one, say my server.py, and then I'm going to also do it in the background. So now this one is the process ID that it is open. I mentioned that on this machine it is, in addition to LSOF, which we already covered, I'm going to do P files and then proc star, and then you could do this and you could see all the socket for everything with the star. The proc file system is giving me the detail, but because I have a process ID for my server, and that process ID is here, I could do a P files /proc/15145. That process ID of that one, you will get the same thing. And notice that when you're looking at it, right here is the port number. And even in this nice here, it shows you the AFI net that we passed on to the socket method, the first parameters. So here, this is good. It shows you. And then if I'm just going to run the client side here, cat -n, my client.py, and then this one is also connected to the 20, so I could run my client.py, and it will give me the our Unix, and then now that process is gone. So now the process ID, earlier I was doing this, P files, it is no longer there. That process ID got closed. On the proc file system, everything else is there, but that's a pseudo file system, but this one is not there. You can see that. So next time I run the same my server here, if I run the same one in the background, I get a different process ID here. Notice that now that process ID on the proc 151551 comes in. And there's a lot of details of this one, which I could cover, like file descriptor and this and that, but this class is a Python class, so I'd rather not cover too much of that information to not get you confused. But for your learning, sometimes I hit certain things. I want to make sure you understand it. With this information that we are talking about the server side, so if you look at the process ID that was here, if I do a P files on it, you can see that again, this is the port number 555, and then all the shared objects that are attached to it and everything else. So if I do a netstat is general for Windows and Linux and Unix and Mac. So you could do and then say grep -i, or this is a number, so I don't need to do -i. In this case, I'm listening to this port you can see there. And then if I just do the my clients again, .py, it will just close it. It will be done. So let's just run it one more time. This time, clear the screen and then do my server.py. I'm running it in the foreground. As you can see, when you run it without the ampersand, it runs it in the foreground. It gives it higher priority. So in this case, let me go on my Windows machine and try to connect from a client outside of the server itself. So on this one, let's go to pasadena.edu, start file, and then, sorry about that. Let me just make this one fit the size you want to see. Okay. And so like right here, you can see I'm on a Windows machine. I'm going to go to lectures and then CD to chapter 12 and clear screen. So and let's say type on Windows, you have to do the type command rather than cat. And then my client.py. So this one is also using same port as our Unix. So this is already set. I don't need to change it. So let's run that one. Say to run it, I'm going to do Python my client.py. That will run it, and you just see receive hello from there, and then right here it did it. So and the fact that I have a host name and an IP address and or a host name colon port number, it automatically just goes from this machine. And then notice that on the client side, this port is a different port. So the tuple that we set up on the server side versus client side, it is opening two different sockets. One socket is for server, one socket is for the client. The client side is coming through this port. This port could be different next time you do it. So like, for example, let's say I run it again here, and then it's listening again here, and then I go again, say, do this, it come out, but watch the port changed. But the port on the port 555 on the server, because it's listening port, that is not changing. The client could be any port coming from this one time. So when we're talking about inter-process communication, this is one of the message passing methods that we are using shared memory and message passing through parameters through two different processes. One process is sitting on the server as a listening process, the other process as a client that is happening there. And then right here, we could do also another example on Windows. On the Windows, you see this script called mylocalhost.py. So if I type, let me make this screen bigger, type my localhost.py. This one is basically using something called Loopback Interface. So Loopback Interfaces by default is an interface that is for IP version 4 is 127.0.0.1. And on the IP version 6, this is 2 colons by followed by a 1. So here, if you see cat etc host, this file has a local host also 127.0.0.1. And then there's also IP version 4 for a local host colon 1. So if you go on Windows environment, let me just show you on Windows the same file. So cmd, if I just go and open up this one as an administrator, run as administrator, I could go to CD to that directory with that one. I want to just open a new terminal, so and the other one I don't have to CD so many times on it. So now this is a command prompt of a terminal, but here I could do go to drivers and then go to etc and type host. This host file, it has the local host, the loopback interface, and for IP version 4 and also for version 6. And then you could have other ports information there, and those ones are local hosts, how to resolve it. In the old days, we all had to just put a bunch of IP address with the host name to do it because there was no DNS. But now DNS is resolving it. You don't have to have it. There's a file called a name server on the Unix side also, nswitch.com file. Let me, like here, you could see nswitch name server switch.com file. This is a main file. So every, like if I do a grep -i for host, how to resolve a host, it says these entries. Look at the files first on the etc host file, etc, whatever file, password, shadow. If it has that entry information, resolve it there. Eventually, it comes out. If it doesn't resolve it, find the DNS. And if there's not found, resolve it somewhere else. LDAP, and those are configuration you set up on your system how to resolve it. But I'm showing you that one just in case if you're interested to know. Here on this one, on the client side, my local host, you can see I'm doing a loopback interface. And as you can see on these machines, fconfig -a, the loopback interface is this, LO. This is loopback. And that's the loopback interface is not allowing any for security purposes, and also it is just an interface that is allowing connection within the host itself. So the outside, you cannot get outside of the loopback interface to the outside IP addresses, external IP addresses. This is very, very good mechanism for security and checking for development coding. So you can see that when you're connected to the loopback interface, you're basically local to that host. And then here, we're doing that one, and I'm going to just do a my server, Python, my local host.py. And then right here, this is just basically doing my localhost.py connection host. No connection could be made because the target machine actively actively refused it. Okay, so that is fine. Port host and the target machine. It might be because of the privilege. Let me cd to run it from here. And do I have the my client? No, I don't have it here. So I have to run it on this one right here. Let's see, cd to users, Wahid, Pasadena, /lectures, no, star fall, star lectures, star 12. Okay, so here I'm going to run the same thing, Python, my local host.py. My local host line 12, connect, no connection could be made because the target machine is active. actively refused it. Actively refused it. The target machine localhost. Okay, notepad my localhost.py. Let's see what is the port 127.0 and this one. I'm gonna just go to a different port. That might be just a reason. So I'm gonna do 5511. Just maybe that connection already I've established previously, and then you can make on the same port already that is listening. So now I do Python my local host, and that is trying to do this. No connection could. The machine is actively using it as connection. My localhost.py. Um, and this is something that at the time that you do this, if this is not allowing you, you have to go on the listen part of it and open up more queue, because sometimes you cannot just make one connection and then you made the connection established there. Going back to the same one again, it will not allow you, because it says no connection be made because the target machine actively refused it. So if I just go on this one and then say host name, yeah, by that one, and then IP config. So on this one, I'm going to go to the loopback interface for this one, even though it's DHCP. Let's see if it gets to the DHCP 254.16. And we could say one 192.168.254.16, and then we just don't do that this way. So this one doesn't matter, 555 is fine. Socket connection, connect, yeah, send all. Yeah, the problem with this one is you can see I don't have a server. That's why this one was happening, this problem. So whatever IP address here I could do, let me not save this and say don't save it. The problem is that my server, so type my server.py. My server.py, you can see, is basically, if you're just connecting to the my server.py, and then my server.py has to be running first to listen. And then my client, my local host is going to connect. So in this case, my server.py has to listen to this port and this loopback interface. So this is ready. I forgot to run this one. Python my server.py. This is now listening on this port. And then if I just go back to another prompt of command prompt cmd, and then let's say netstat minus an and then grep for 555, you can see, so not grep, sorry, find, and this Windows, find, find, and then since I'm doing find, I have to put it as a string, and it finds it. So I'm listening to port one right here. This one, it is basically showing me that I'm listening to it there. Now I could go to Pasadena fall, and then what was the lectures in chapter 12. So sorry, lectures fall. Yeah, start at 12. So this one, and now I'm on the client side here, clear screen, type my local host.py, and then this one is still connecting, but I forgot to change this one to the same port number here, 555. So let me just do this. Sorry. So here I'm going to do netstat. I make sure that the port that I'm listening grep for 555. Sorry, not grep. Find slash 55. So the port that I'm listening is 555. So let me just do that, 555, and then clear screen. So this is the port that I'm listening, and then notepad my local host.py. I'm going to change this one also to 555 on the client to go through the loopback interface, save it, and then just let's now run it. So my client, and I'm going to do a Python, and then notice this one, I'm running it here. If you just press enter, it doesn't happen anything because it's running here. So I'm going to run this one to connect to it, and you can see that it says received hello from our unix.com on the client side, and then right here it says the connection was established through the loopback interface. So you could use the loopback interface, but loopback interface is for local host, not outside of it. That's why it's on the etc host file that host name is defined as localhost. Okay, an alias for it. Do you have any question? Okay, so I'm seeing 12 now. That is good. And now let's just go to the topic and see what where we are on the discussion. So we did discuss LSOF, P files, Wget, SSH, curl. Wget is also a widely used tool similar to curl that allows you to basically get some download some website or documentation from something or somewhere. So let me give you an example of wget, for example. So if I go to our unix.com, you could see that it comes out with this page, and that is my default page. So if I go to same thing with another documentation, like let's say I'm going to go to our unix.com and then port, same port, man pages. You can see that it's coming with this documentation. And then I'm coming with this interface. So now if I just want to read what is inside of this index.html, curl and wget is a very good tool for that. So it's not on Windows, you have to download the version if you are using it for Windows, but by default on Linux it comes with it. So, and with Solaris you could have it depend on what the distribution you installed it. If it doesn't come, you can always use package add to add the package, or pkg to add it depending on what version of Solaris. So here I could say which wget, and if I have that wget, let's say here I'm going to make a directory, say temp, cd to the temp. Now if I just say wget our unix.com port 8080, that one automatically downloaded the main index.html page here. More index.html is the same source code that you saw it on the browser. Okay, So the next time I do the same thing, it's going to get a second copy of it. And then it's going to put like .1 on .2 and so on. So trying to connect, and for some reason it took longer this time. And then you can see the size of the file are the same. So if I just do a wget on a URL like this one, since let's say we say wget http / let's say python.org. You could get that one, you see it now, and the index.html page is different than the other ones because this is for python.org. So let's see, sorry, let me just rm, the python.org is the third one. Since it has the same name, this is coming for python.org. If I do wget google.com, then it's going to go number 3, and that's for Google right here, the source code. So this is like details of the entire page, which I will show you also on Python when we do the request after the break. But let's see if here I'm going to delete these ones, rm minus or f star. I don't need all of those. So I'm going to say, since I'm on this temp directory, I'm going to do a wget with, let's say I'm going to go http colon our unix.com colon port 8080 / man_pages / index.html. You can see that it comes out, and this is a different page than the front page because I put the path to where the man pages is. So this page is basically here. You can see that it's all the HTML page. So now if I just say rm index.html, and I could do the same thing, and instead of putting this thing, I could put the HTTPS. So HTTP stands for Hypertext Transfer Protocol. HTTPS is a secure version of Hypertext Transfer Protocol. The S is for secure. So the port, if you don't specify, by default is port 80. And if it is secure port, is port 443. But if you specify, like here, it is going through HTTP, it is port 443. I mean 8080 if you specify it. If you don't specify, it's 80. So on HTTPS, if I say HTTP ben.org / let's say get, if I do that one, it's basically giving me the get on the HTTP, but notice that it was HTTPS, secure port. So it goes through a certificate, SSL and TLS there. SSL stands for Secure Socket Layer, and TLS is Transport Layer Security, Transport Layer Security, which is an enhanced version of SSL. It's a newer version. TLS is the newer version of SSL. The old version was SSL, Secure Socket Layer. So here, if I'm just going to look at this index.html here, sorry, it came out as get. You can see that the page. So the get has this parameter on that page because I'm getting this. So it is almost like a, not almost, it's actually, the format is the JSON, which stands for Java script object notation. It has this brace, which is for JavaScript and Java, the definition of a block of code. And Python, you're doing indentation, and JavaScript, Java, C, you use braces to do it. Now, and this is one key and then one value, key pair value. Sometimes within the format of this JSON object, you could have an array, you could have a dictionary, you could have tuples, anything. They're all defined in there as kind of key pair values with these kind of blocking of codes within the braces, and then separated by comma. And then sometimes if it's an array, it is kind of between bracket, and if it is less, it's between bracket as well. So in this case, we will examine these ones also with same thing. So here, if I just do the wget with this one, what if I do a post? Get the post, this one. Now the post that says method not allowed, because at post you have to actually push something to the HTTP bin. You have to have a key pair value, so the method that you're using is different way than just downloading the things. Now we're uploading, posting something, and in the form we're modifying something. So you have to have a payload or a dictionary to upload there, which I'm going to show you on Python request method next. After the break, actually. So this one, let's do the curl. See, now this one did not come out with the name. You could see the post was not allowed, so we could not do a wget with it. But let's do a curl. Curl, we could do the same thing of that method of this get, and instead of wget, let's do a curl. Curl is also doing the same thing, as you can see. But the option of curl is really neat, because you could just do, with wget also you could do certificate and everything, but curl is written mainly in Python or Perl. It has a lot of options with this. I don't recall if it was Perl or Python, but it does have a lot of options. You can see curl -h, you could see a number of options here. So let's say if I want to just rm this get, and then I do a get curl -o, and then say http://http ben.org/get. Notice that the -o is not going to work if I just type it in without any argument. Now, -o meaning send the output, and instead of get, I say get.info. Let's say I gave it the out file name, what I want to name it here. So it says connection refused. So let's see if -o this, and then I'm going to put -o here as get_info. Connection refused. Oh, yeah, it is making sense. And the reason is not because where you put it or what name you put it, is because of this D. I put an extra HTTP D. That was the problem. So now get.info has the information. So the option that are curl -h, you can see there's a number of options here. You could do it with the user-u, and that's P for password. You could specify a lot of options here. I've used these ones extensively from time to time, but you don't need to learn all of the options now if you're not using it. If you use it, yeah, it does require this one. Same thing with the wget. So wget-h will give you a lot of options here, that how you want to download something, or you could do even this one for websites. Sometimes there's companies that they host your web servers, and then they just tell you to just get the pages downloaded, but because you have authentication mechanism, you can do it as a developer and sync your system as a backup in case your system has some kind of downtime. You already have a backup. It's good to at least have a one-time backup of your system doing this. But you on the control panel, a lot of times they do have provide you those options to download the stuff there. So let's do this. Yeah, this wget and curl is also good if you don't want to do scopy or SSH or to a machine, and you just want to get one file or maybe one tarball files or something from the internet. So like if you go to let's say python.org, and then inside python.org on the download page there's a documentation or something that you just say, okay, on the download page I'm looking for certain one for maybe on this. If you go on these ones you can click on here, or you could right click and say copy link address, and when you do copy link address you get this link address and then 3.9. So I could see if right here, let's say go to the temp directory, make directory temp. Let's see if I have wget here with this. And notice that this one comes in as on the temp directory minus LTR. So it came out as an index.html, which I didn't want to have it this. This is still not the detail of it. But if you have the actual tarball path, then you can download it that way. So this it was not a good example in the sense of in this file rm index.html was not the right path. cd to temp. Okay, so here, if this file, what I'm looking for, it is when you just click on it, it has, when you look at the path here, has a path to it, then you can download it. A lot of times I'm doing that one for certain kind of like tools that I need for our operating system, or certain like Python version, or maybe GCC version and everything. And they provided as a tarball files and ganzip files or something, then I use those ones. I wonder if you click on here, it actually, yeah. Let's see if right here, PEP 537. Yeah, and then right here in ganzip source file, this one. So this one is MD5. Okay, so this is the files that we are looking for Windows. This is the source. So I could get this one, say copy addresses space. This one is the one that I was looking for. And by doing that, and let's see if I'm here, clear the screen. On this machine, I don't have anything at this directory, so I'm going to do a wget on this. And you see the tar ganzip file format, but this is Python 3.9. So basically, this is going to download Python 3.9.0 tar ganzip file. Then I have to untar it. And then since this is my Unix machine, which is Solaris 11 with Python 3.5, I can upgrade it to 3.9. But in order to upgrade it, because this is source, this is not the binary. As you can see from this page, it says source tarballs. That means all the Python scripts and modules are there. I have to compile it to on this platform. For each platform that you do is different way you can get it. But I can get the same one also on my Linux one and this one. So right here, I could rmget.info, and then here do the same thing, wget, same path here. This will just do it. This one was so fast here. Clear the screen, and then right here I have it. So now if I say file, this one is, you see that is ganzip format, tar ganzip format. So this command, store the tar ganzip format, and ganzip it, and then I could do tar xbf store.tar. That would do extract Python 3.0. But notice that Python 3.9, sorry, Python something dot zero. If you create this one and then inside here, this is basically my Python there that was sourced. So that means that there's a config here, there's a make file, and then inside this config, the configure, and then make file, these so makefile.prep preparation if I do it. But this configure based on my machine, if I look at the Python-V, this is 3.69. 3.69. If I want 3.9, then I have to configure it as so. I could do that configure to use the default one configuration, or put -- prefix and then put the path where I want to install the new version of Python, and then let's say user local, whatever directory I want to do it. I could specify the path. At this time, I'm not going to do that one because we need to continue with the rest of the class, but this is also done. Similar to that one here, you could do one command also, or you could do two commands. You could extract that one and similar on Solaris platform. So this is good. We downloaded that to using Wget. And then you could do also scopy. Last week I showed you scopy. So scopy and SSH and secure FTP, all of them are provided there through same SSH. SSH is the one that we have been using it in the past weeks, and then scopy is to secure copy, secure FTP, file transfer protocol. When DARPA originally was invented, TCP/IP package was introduced. Inside the TCP/IP package, just secure FTP, scopy, SSH, telnet, rcopy, rcommand, and all those commands that are related to do internet kind of activities between two computers, and then were produced, and we have been using it. Curl we used, enterprise communication we used the example. This we used, we explain all of this. HTTP we discussed, traceroute we did, traceroute we did, ping, DNS lookup, hostname CTL. The service management facility, that is something similar to system CTL on the Linux side. Those ones are on the services for Windows, and Solaris is SVCS, SVCADM, service management facility, which allows you. And these commands we just discussed now. And these are the files that are related to the configuration files for network, for all the options. Some of them we covered it tonight. If you have question, I'm here to explain all of that one as you have question. Let's just finish this page. That one is done, and then we are, what time is it? It's 8:39. Okay, we still have time, that's good. We can go to this page on modules. Let me go back here. Do you have any question? You know, we get to know the environment better if you guys participate with questions, and I do appreciate any question that you have, and I'm there for you to just help you out with your questions, as well as some of your question may not you know, help you as much, but maybe it helps your friends or other students at the same time by listening to the same topic, they may just have the same question. So you're welcome to communicate through the lectures or lab activities, as well as after office hours. So let me see what we have. On this one, we already covered. Okay, for this one, I also have a number of videos that are from your textbook that is already the author of the book has discussed. So I put it there that you can listen to them. And then I have from previous semester some of the videos that I taught, and then I'm going to post this one online as well. And then sometimes because I'm teaching the same class on Saturday, if you want, I could make that one available to you as well. Last time I asked the students of Saturday, they said we like to see the Thursday. Yeah, it would help us. So if you do feel like that, let me know. I'll post their videos that I give lecture as well. But I'm doing each class separately, so some of the materials I may just cover twice, and some of the materials might be new on each discussion. And so let's see. Right here is all the videos and docs in the chapter 12 itself. They're available for you. But if you go to the topic right here today, we covered this one. We covered Windows, Linux, this, and then this is something that I covered last spring as well. It is extensive there. There are some examples of this that you could see, for example, for socket programming, what you need to learn this environment. So the URL lab we are going to discuss after the break, URL lab 3 and then request method, and I'm going to show you examples, and we're going to actually go to those definitions. But these are examples, and then some of these examples that are with post and get, you can see I'm getting sometimes using python.org, sometimes I'm using HTTP bin post, sometimes I'm using W3 school, or I could use any IP address, like my own IP address, my websites or something. As long as it helps you understand the materials, I jump into that example differently. So when you look at it, saying that how do I test that one, some of these examples, or you can test it at your computer going to the same websites, going to test that one. Like here you see that W3 consortium reference request delete.asp. They wrote it in actually ASP advanced server pages, which is a Microsoft version of equivalent to JSP, Java server pages of Java. And Java server pages and servlet are no longer as active because a lot of people are writing different tools with request and with URL labs and other kind of modules that are available on the internet now with SOA. But they are still great. Servlets are on C++ and Java and other Swift kind of tools. They are used extensively for connecting to servers and doing client server kind of data, or SOA kind of service oriented architecture, or other type of connection through HTTP, depending on the needs of the client. So right here you can see that some of the examples are showing. I'm not going to go to each of these examples one by one because we don't have the time for it, but I expect you to just look at, for example, this one. It says request get HTTPS W3 school. So all it does is import the request, and then goes to this, and it has a timeout. If within the 2 seconds it doesn't resolve, then it times out. But then it gets a status code, which means that within 2 seconds, this website has to respond successfully. And the status code is going to return a 200, meaning it's successful. If it's 400, the status code, it means failed. The website is not up and running. And then there's different status code from HTTP protocol. You just have to familiarize yourself depending on what you do and how you're getting the status code. And based on that one, if it's an error file, you have to handle like page not found or those kind of things. And then you could do that one with Python with try exception block. So like right here, there's a post method. As you could see, when we were doing the post method, it was saying permission denied, because when you're posting on this page, this post directory has to be in the path of this URL. So a URL normally has a scheme. The scheme is either HTTP or HTTPS. HTTP is Hypertext Transfer Protocol port 80, and HTTPS secure port, which is port 443. If you don't define colon 443, HTTPS is showing a lock. It not automatically, it is assumed. So if I go to this page on the site, on the browser, you see that this page is going to resolve to HTTPS there. Right here, it will resolve to HTTPS, and then this one you can see the lock, and then from there everything that you have a get or post is going to be available. But because you can get a /get maybe /get and you get that page, but you can't do a /post without something. So the post requires some kind of keyword argument. So the keyword in this case it would be, let's say I could say key one and then space value one. If this one gets a hard code encoded, then there's a %20, but this is, it still says not allowed, because I have to do a different method to post to this one. This is the method that I'm calling is right here. I'm using a get kind of options. So this is not gonna allow it. The only way that it's allowed here, like I have here as an example here. So you define a payload, and then by payload, when you do the request method, the post method requires 2 arguments. One is the URL, and the second one is the data. The data in this case is payload, and payload is a dictionary. So you define a dictionary here, and then you pass on this key pair values to it, and then that will be posted there. So if you do this one within your request method or this, that would work. There. Let me cover one more thing here, and then we jump on back to, yeah, you see here there's when the ports like page cannot be found, you get a status code of 404. So and then the key pair value, in this case, on this example, you can see when we did the payload, we defined this, and then at this time, and the data is payloaded, but then when you do a print R, which is a response dot text, then you get the entire things, and then part of the form, inside the form, the key pair value are there, which is part of the payload here in the form. So that's how it gets posted into the form. And then you see that JSON is null. origin is this. And so there's a lot of key pair values everywhere that you can get for this one, which I will show you when we do the request methods. There was one more thing that I wanted to discuss here. Let's see. Yeah, the socket. The socket, when we were talking about socket, I mentioned that I'm going to go to PyCharm, and then let me just open one thing. I'm going to just say file new, and that way you could see exactly when you create a socket, what happened here. So Python file, I'm going to just say test1.py. Just as a test, we don't have to do anything. So here I'm going to do the usual thing, Python, and then say testing, testing on socket. So if I just do that one, and then here say import socket. So at this time I did import, I have to use the socket. So if I say with socket.socket, and then as soon as I use this parameter here, now it knows that I'm using this. Notice that PyCharm is very helpful in terms of the IDE, Integrated Development Environment. It says, okay, now I'm using the socket module with the socket method, but inside here within the left parenthesis, it expect me an address family. So the address family, I don't know what they are by just memorizing them, right? So I'm going to just say socket, socket here, and then I'm going to put a dot here, and then let's see if it helps me. It does help me. So this one now, it says these are the address family that are available to you. Which one do you want to use? Since I was using the socket .inet, so I could go in there with address family with AF first, and then underscore, and now it just helps me further say which one of these one do you want. Since I want the inet, I could just click here, and then this is inet for IP version 4. If I'm interested in IP version 6, then I use this. And then now watch this one I'm going to use, that one is there. Now I'm going to put a second this. Now it says, what is the next one argument? So I'm going to use socket here again, dot. And then here, that is the option that are there. That what I'm looking is for uppercase sock. And so let's see if that is there. Yeah, sock somewhere there. So I'm going to type in sock. And then right there, you have the datagram and then streams. A stream is for TCP, and then a datagram is for UDP. So I'm going to use sock underscore stream. So this is what I wanted to show you, the options that are there. And then now if I just say I want to bind to it, then I have to do this one. You see that this bar is showing a red thing because I did not say as for socket. And then I have to put this. Now my socket module is available. So if I do a dir of s, you could see that the module that are available. Here I could say s dot, and then the bind method is there. You can see it's what am I binding to? So I'm binding into an IP address and a host name. So the I could say host, comma, IP. And then I have to define those two. So I'm going to come here, say host name. Host name is, I could do other socket method to get the local host, or I could just say right here, I could just say host name is our unix.com, like that. or I could say socket.socket.get socket by name. You could do get socket by name, get socket socket name, and then whatever the socket name is there, it automatically returns a host name here. I could get host name by name, and then this one I need to do get host name. Let me just get host name. Get yeah, you could do this. So get host name like this also, just to get the host name from the socket. And then the port you could do our port is equal, let's say port 1234. This port number cannot be a string, so it has to be this. And then this is not IP address. This is actually port, sorry. So port, you do this one. And then once you open that socket, then this time you have to, you bind it, then you have to listen to it. And then you say listen, socket.listen. And then normally when you listen to it, it's just to that port and that socket. And then after you did this one, you do bind and listen, then now you have to do kind of like, so you did the bind and then you did listen. And at this time, you're going to get the connections. Accept the connection. So accepting the connection, you have a connection and an address from the client, and then you say accept, s.accept, socket.accept, and then accept. So that's the self itself. And then now with con, what do you do? With con, you could do start whatever you want to do. So this is important because all of this information, like you see with con, when I type in with con, automatically it comes in the things that are there. So IDE is helping you. I'm gonna stop here with con, and then we could just do other things to say connected by. You could just say print connection was established by, and then give the client name. So you can make even this one as a function as this, and then say by, and then say here the address that you got here from there. That way you could see that the connection is done, and continue on. Okay, so what I wanted to show you was this part, because this is option and that IDE could help you. If you didn't memorize all the parameters, that's not a problem. You can still do a search somewhere and then you get it, but notice that this is a tuple. So by doing this, it's you have to do tuple. And then when you compile it and run it, it is there. Let me just give you a 10 minutes break. It is 9 o'clock. Let's come back at 9:10, and we will continue after that. If you have any question, either stay for the question or just take a break and then ask me question after break. Okay? I'm going to stop recording for now, and then we continue when we come back. Thank you all.